Hello class, today what we're going to look at is the equations of parallel and perpendicular lines. So first, before we get into that, we're just going to start with the equation of a line. It's writing the equation of a line with a given slope through a given point. And there are two ways to do this that I want to talk about. First, we can use slope-intercept form, which hopefully you all remember as y equals mx plus b. All right. The other way that we can do this is point-slope form, which you should have learned last year in Algebra 1, but I know most people don't use this all the time, not as familiar with it. This is y minus y1 equals m times x minus x1. All right. So I'm going to solve this equation here. I'm going to write this equation both ways, just so you can see both different ways, and you can decide for yourself which one you like better. All right. So if we want to do this with slope-intercept form, I know my m is your slope. That's 3 right there. Okay. So now I've got to figure out what b is. What is my y-intercept? Because they didn't tell me that. So what we do is we plug in our slope, we plug in our x, we plug in our y into this equation. So y is 5 equals m, my slope, which is 3, times x from the problem there is 4 plus b, which I have no idea, so plus b. So we multiply that together, so 5 equals 12 plus b. Subtract the 12 from both sides, and so minus 12. And I end up with negative 7 equals b. Now I can write my equation. So y equals m, from my problem there, 3, my slope, x plus b. Well, plus a negative 7, so that's just going to turn into minus 7. And there is my equation. All right. Now I'm going to do this with point-slope form. So this time when I plug in, I'm going to leave y and x where they are. I'm plugging in for y1 and x1. So I have y minus y1, which is 5, equals, m is still slope, so 3, times x minus x1, which is 4. All right. And now all I've got to do is simplify. I just want to get y by itself is all I'm doing here. So I'm going to do two things. First, I'm going to distribute the 3 into the parentheses. So y minus 5 equals 3x minus 12. And then I add 5 to both sides, so plus 5, because I want to get my y by itself, and y equals 3x minus 7. And again, you see, you get the same answer either way. Doesn't matter, slope-intercept form, point-slope form, whichever one you like. Personally, I like point-slope form, but I know most geometry students like slope-intercept form just because they're more used to it. We've been dealing with that since like 7th grade. Okay, so what we're going to do in this one is we're going to write an equation of the line passing through point P that is parallel to the given line. And then we're going to graph the equations to check that they are actually parallel. So, let's see, we've got a point. Point is negative 1, negative 4, and then it gives us the equation of line y equals negative 6x plus 8. So they gave us a point, but they didn't give us a slope, right? But they did tell us that the line that we want is parallel to this other line. Right? It's not this line, but it's parallel. And that's going to help us with slope. Because if two lines are parallel, then they have the same slope. So the slope of the line they gave us is this negative 6. So the slope that we want is going to be also negative 6. So what we're going to do is we're just going to work this out and get the equation of the line. And again, we can do this either using slope-intercept form or point-slope form. It's up to you, whichever one you like. I'm going to do slope-intercept form for this one because why not? Okay, so y equals mx plus b. Always helps to have that equation in front of you. And now we're just going to plug stuff in. So y is negative 4 equals m. M is negative 6 times x, which coming off of that point there is negative 1. Plus b, which I don't know. That's why I got to do this work to figure it out. Okay, So now let's just work this out here. So negative 4 equals negative 6 times negative 1 is a positive 6 plus b. And then we're going to move the 6 over, so minus 6 to both sides. And I have negative 10 equals b. So my equation, with everything plugged in there, is y equals m, negative 6, x plus b. Well, b is a negative, so it's going to be minus 10. All right? So this is the equation of my line. And now let's graph these two lines and see if they really are parallel. So let's see. The first one has a slope of negative 6 and a y-intercept of 8. And that means we're going to have to go up by 2s on my graph here to make 8 fit in. And negative 10 down there, yeah, it's going to have to go up by 2s as well. So we'll go up by 2, 4, 6, 8. So there's my y-intercept right there. And a slope of negative 6 means I'm going to move down 2, 4, 6, and to the right 1. And let's go ahead and do it again. Down 2, 4, 6, and right 1. And down 2, 4, 6, right 1. And now we want to draw a line as straight as we can on this. Yeah, that's pretty close. And now we will draw the other one, the one that we just calculated. So it's going to start at negative 10. That's our b, that's our y-intercept. So that's where we begin. So negative 10 right there. And I can't go down 6, so I'm going to go backwards. So I'm going to go backwards 1 and up 6. 2, 4, 6. Backwards 1 and up 2, 4, 6. Backwards 1 and up 2, 4, 6. Right there. And see how straight of a line I can draw on this one. All right. So there are two lines, and we can see that they look fairly close to parallel because I can't draw a straight line. Okay, so on this one, let's see here. Write an equation of a line passing through point P that is perpendicular to the given line. Graph the equations of the lines to check that they are actually perpendicular. Okay, so we're going to just write the equation of the line. Let's see, it goes to point P, 4, negative 3. And we have another line, and we don't have the slope again. That's fine, because it tells us that these are, this time they are perpendicular, not parallel. So what does that mean? Well, what that means is that the slope is going to be opposite reciprocal or negative reciprocal. All right? Opposite reciprocal. Opposite just means we change the sign. Reciprocal means we flip it over. Technically, mathy definition, the slope of the first line times the slope of the second line is going to equal negative 1. All right. Effectively, what it means is you're going to change the signs and you're going to flip it over. All right. So if the slope of your first one is negative 7 halves, then the new one is going to be positive 2 sevenths. If the slope of the first one is positive 8, the slope of the perpendicular line would be negative 1 over 8. Okay? That's what it means. So we take the slope of the line they gave us right there in front of the x, 2, and we're going to flip it over so it becomes 1/2, and then we're going to change the sign. So instead of being positive, it's going to be negative. And this is going to be my m. And now I've got a slope, I've got a point, I can plug this all in. And I am going to use point slope form this time because I did slope intercept form the last time. So here we go. We have the equation y minus y1 equals m times x minus x1. And we plug stuff in. So y minus the y value off of the point. So minus a negative 3 is going to turn that into positive 3 equals my slope, negative 1/2, times x minus the x value for my point, which is 4. All right, so first thing I'm going to do is I'm going to distribute this negative 1/2 in there. So y plus 3 equals negative 1/2 x. And negative times negative is a positive. So 1/2 times 4, well, half of 4 is 2. And now I just move my 3 over. So minus 3, and y equals negative 1/2 x. And 2 minus 3 is negative 1. And this is my new equation. Now we want to graph both of these. So the first one is 2x minus 3, and the other one's, okay, so my y-intercept is negative 3, and that'll fit on here if I go up by 1s, and this one has y-intercept negative 1. Okay, so I can go up by 1s on this one. Don't have to change my scale. So negative 3 is 1, 2, 3, right there. And I have a slope of 2, so that means I'm going to go up 2, right 1. Up 2, right 1, up 2, right 1, up 2, right 1. And I can go back 1 and down 2, like that. So let's see how straight I can draw this line. Hey, that's pretty good. Okay, and now we're going to draw the line that I just calculated. So it has a y-intercept of negative 1, so negative 1 right there. And I have a slope of negative 1/2, so that means I'm going to go down 1 and right 2. Down 1, right 2, and I'm going to go ahead and back up, so that'll be backwards 2, up 1, back 2, up 1. Okay, and now let's draw that line. And you see, those are perpendicular. They intersect at a right angle. So we did it correctly. Right? So that is writing the equations of parallel and perpendicular lines. Important thing is, if two lines are perpendicular, then you have opposite reciprocal slopes, which means you flip it over and you change the sign. If it's positive, it becomes negative. If it's negative, it becomes positive, right? One of these will always be positive, and one of these will always be negative. If they are parallel, they have the same slope. Both of them have the same slope, -6 on both of these, right? Whatever the one is, the other one is, they go the same way, like railroad tracks. They're parallel. And then you have two different ways to write the equations of your lines. You have slope-intercept form, or you have point-slope form. Either way is fine. It's just up to you, whichever one you like best. And that's that. Hopefully you found that useful, and I will see you in the next video.